Hello and welcome to another exciting episode of 2353. This is a supplemental lecture. I'm your host and professor, Dr. John Baugh. This time we're going to be talking about linked chains in Java. To make sure that you understand the different components that make up a linked chain, if the other lectures were not clear in the book and the other information provided, I will go over this and we will do an example to make sure that everyone's up to snuff. So a node is part of our concepts that we have to understand. The linked chain approach is going to be an alternative to the array approach. With an array, we have random access memory, random access, we can access any cell in the array because it's all contiguous memory. It does a little bit of math for us behind the scenes, and then we can point to the particular location in the array to get the element living there at that cell. We can't do this with a linked chain, but we get other advantages. For example, overall, we're not wasting as much memory in many cases, and if we don't know how many items we're going to need ahead of time, then a linked chain might be a good alternative. So the node is a major part of understanding the linked chain. A node is a separate class, a separate entity from the chain, but it can be considered a component or composed of. The chain is composed of nodes. So a node can exist independent of this list, and in fact it does so when it's first created. One part of the node is going to involve data. Now this, I say arbitrarily one part. It could have multiple parts if there's multiple pieces of data, or you could have one other reference to another object that holds data. That's fine too. And then the reference is going to be on the other side, if we visualize it this way. That's going to hold a reference, which is a memory address, of the next node in the chain so that we can keep track of the actual chain. So what is the linked chain in the grand scheme of things? Most of the time developers just call this a linked list. I would usually make a distinction. I would say a linked list is the linked chain implementation of the list ADT, just like an array list is an array implementation of the list ADT. So you've used probably array list before if you've been dealing with Java for any amount of time. And this is just kind of the linked version of that. A linked chain represents a chain of 0 or more linked nodes. It holds a piece of private data, a node reference, that will point to the first node in the chain. And there are variations on this, of course, and we don't always call it first node or things like that. For a queue, we might have front and rear, so we might have two nodes, like a linked chain with two references. And you might even have a modification of the actual node as well that has a reference to the next and a reference to the previous. That's called a doubly linked chain or a double linked list. But in our case, we're just going to use a singly linked list that has a single reference to the first node. This is actually more like a bag than a list because the order won't really matter for us. Here's the example that we're going to use so that you can understand how the linked chains work in action. There are three classes that will make up our example: inventory node, inventory list, and inventory demo. We will make three different Java files, Java classes, inventory node, inventory list, and inventory demo as well. The node will represent individual nodes that represent individual products and quantities. So the name of the product and the quantity, that will be our data. And they will also point to the next node in the chain. That's an implication. The inventory list will represent the whole list itself and hold a reference to the first product in the list, and then that product will hold a reference to the next, that product will hold a reference to the next, and so on. Inventory demo will be the only class in our project with main in it. A lot of students have been putting main in multiple locations all over the place, and while you can have a main method in pretty much any class you want, it's generally a good idea to keep it in its own separate class where it can be used and serve as the driver program or client of the inventory list. So let's start by creating these three different Java classes in separate files. So we'll go over here. I have already created a project in Apache NetBeans. So we've got this inventory example project, and under the source packages, I have the default package. Doesn't really matter which package you put it in, but I will be creating 3 different files. We're going to have, according to this, inventory node, inventory list, and inventory demo. So we're going to do inventory node and just create that. Create another one. Oops, not a package. Don't need a package. I'm going to create an inventory list class. We're going to also make the font bigger, don't worry. And inventory demo. Let's change the font size under tools options so that you guys can see it. And I think I'll make it maybe size 20. That should be sufficient. Okay. And we give it a second. There we go. And it has made the font larger. Oops. It gets a little squirrely sometimes. Okay. I don't know why it's doing this. Very strange. Okay. Okay. I think there's a little bit of a bug in it, but no big deal. Okay, so we got that. We'll delete all these extra comments, and we just have inventory node, inventory list, and inventory demo. So far, so good. In the demo, I'm going to create public static void main. And we will come back to this when we're ready to use it. But we will start with the node. That's where we'll start as far as implementation is concerned. So we're going to create this inventory node class. It needs private data, and that will include a string representing the product's name, an integer representing the quantity, so those two are both counted as data, and then reference to the next node. That is part of the structure. So it can provide the public methods, a constructor that takes the name, quantity, and next node, and also getters and setters for the name, quantity, and next. All right, so let's do that. We're going to go back over here, and inside our inventory node, we're going to do private string product name, private int quantity, and private inventory node. And we're going to call that just next. That's the reference to next. Okay, so again, this is a visualization. Name, quantity, and next. And over here is how we turn it into actual code. So we'll say that's the end of the class in here. And we're going to do a constructor, inventory node. Might want to spell it right. Inventory node. And it's going to take the product name, a quantity, and the inventory node next. So what they want the next to point to if we want to do that. Or just pass a null pointer into it, however we're planning on using it. So that's the constructor. This is pretty straightforward. So we're just going to do this dot product name equals product name. This dot quantity equals quantity. And this dot next equals next. All right, so that's how we just take care of this class itself. Now we need the getters and setters. So public string get product name. That's just going to return the product name, right? So that's a get product name. Getter for product name. Okay. Now we do get quantity. That will return quantity. That's the getter for quantity. And continuing, we're going to do also a getter for next. So public inventory node next. That's just going to return next in case we need to access that. And getter for next. Okay, now we want the setters, right? So we did the getters, now we're at the setters. We're going to do public void set product name if we ever need to update it. And you can choose whether to have these or not. If you're not using them, we don't need to have them really. So we're going to do product name there. This dot product name equals the product name. So it does very much what the constructor does, but just for one element. So that's in setter for product name. Public void set quantity. That's going to take an int quantity. This dot quantity equals the quantity passed in. That's the setter for quantity. And then we're going to do public void set next, if we need to do that. Inventory node next, right? This dot next equals next. End setter for next. Perfect. Now, what we're going to do is we have our node, we have the thing representing this, and we need to be able to use it. So now we're going to create the inventory list. For this one, we're going to need a private reference to the first node in the list. Remember, this one isn't the node, this is the list. This represents the list. Now, I don't need to keep track of each node separately, because then that would require an array, and there's no reason for us to even use a list. So in this case, we only keep track of one node at the beginning, and that will be the first node in the list. Now, for our purposes on this one, the order doesn't matter. For something like an actual list rather than a bag, which is really what this is, we would need to keep track of maybe the ordering, and it would affect how add and remove and other things work. For queue and stack, most definitely that would affect those as well. So we're going to have two inventory list constructors, one with no arguments setting the first node to null, and one with a reference to another inventory list which copies it. So that's going to be the copy constructor. And again, the copy constructor, when it copies it, the order doesn't matter, so it doesn't have to be in the same order as long as it has the same elements. Add is going to take the name and quantity and add the node to the list. Remove will take a name and find the corresponding node, and it will remove the data. We'll use a clever trick that they use in the book for the bag by copying the first node's data into that node that we wanted, that had the data we wanted to remove, and then just remove the first node. Because we'll then have two copies of the first node's data, and we can just remove the first node and basically bypass it. Print will go through the entire contents of the list. So the add method does something like this. You create the new node. This would be separate. So it would look like this, and then first node would be over here to start with. If we only have one node in our list, it could have arbitrarily 100 million nodes, it doesn't matter. So as long as we have memory for it. So this is the current first node. And then what happens is we create this new node and add the data to it. So for example, maybe we have 100 carats, and then next would actually be pointing to nothing yet. So we're telling it now to, actually, wait a minute. We're telling it to put the link here. So we're making our next of the new node point to the current first node, and then we make ourselves the first node. That is going to add that item to the front of the list. So let's work on this. Well, I guess we can talk about remove too. Yeah, we'll do that, and then we'll talk about remove in just a second. So inside here, I need private inventory list. First node, public inventory list, and then we set first node equal to null. So this is not, it contains no nodes at the beginning. So in for that constructor. The other constructor takes another list, we'll just call it other, and this is end of the copy constructor, or copy CTOR for constructor. We also need add, so we can get those stubbed out and get them ready. String name and int quantity. Remove by name. We don't specify the quantity because we're using it to look for the item. That's the end of remove. And we can also add print, and then we can add a helper method that we will need very likely, because of the copying the data from the other list. So let's see what happens here. If I do print and then we could do end of print. Since we're the same data type as the other inventory list, we don't really need to provide a method to do it, but if you preferred, you could do a private inventory node, get first node, or what have you if you wanted to. It doesn't really matter, isn't going to really affect it. We will see what happens. So, we got the constructor written, the original constructor. Add is probably the next simplest one, so we have to do a couple things here. We need to create a new node, so this creates it independent of the list, and then link it in to the front of the list. That's what we need to do. Inventory node new node equals new inventory node. I'll take the name quantity that's passed in, and also I'm going to pass in first node, because even if first node is null, it should, incompatible types. Inventory list cannot be converted to inventory node. Did I goof? Let's see if I goofed. Inventory list. And we got first. Oh, yeah, this is wrong. This should be inventory node. Sorry about that. This is inventory node. So first node is passed in, and even if it is null at the beginning, in fact, this actually sets itself to null automatically, but we're doing it explicitly just so we can see what's happening. And then right here, first node will be passed in. This node will just be floating out here by itself with no links yet, and it won't be set to first node. So this is the state of affairs right now. We have the data because we set the name and the quantity, and next is set to null, or set to nothing. Eventually, or actually right when we call the constructor, I guess we did it this way, we have next point to the current first node, but it's not really part of the list because we can't really access it from the list. So the next thing we need to do is say, hey, you're the first node now. So the old first node is still linked in because we set it using next, but now we have to say link it in by saying first node equals new node. Now I'm not changing what the node is, I'm changing the reference to which is the first node. Remember, because this holds a memory address, it doesn't hold a node. It holds a memory address containing the address of a node. Okay. The next thing we might look at is, I guess we'll do the remove, because that's more of a fundamental one. Now the remove has to look for an item, and the order doesn't matter for us, so we're just going to replace the node to remove the data with the first node's data, and then remove the first node, because it's easier to remove the first node. Otherwise, we could just bypass the node, and we'd have to keep track of previous and next. So let's first inventory node walker. We need a walker because we can't keep updating first node because that'll lose the list. This is private data. This is just a local variable holding the address of the first node to start off with, but we can modify walker to point to new data as we need to. So walker, while the walker is not null, we're going to look for the item that we want to remove. So here's what we're doing. Now I could do this all in one string here, but I'm just going to say product name equals walker.getProductName. And then I'm going to, at the end, I have to do walker equals walker dot next, or get next. Did I call it next? I think I just called it next, didn't I? That doesn't seem right. Let's call it get next. That makes much more sense. Get next. So I just changed the name to get next right there. And that's what we're doing. We're setting the walker to the next element in the chain. If it ever gets to null, we know that we're at the end because of this structure. Oh, we're here. Oh, we're here. Oh, wait, now we're at null. So there's nothing left. We know that there's no more nodes left. Okay, inside of here, so we get the name. If the product name, now you're just dealing with a string. There's nothing magical here. If it equals the name that was passed in, and if we find the element we're looking for, we set walker.setProductName. This is where we grab the data from the first node. So first node dot get product name. and then walker.set quantity, we're going to do first node dot get quantity right there. And then now remove first node. So now we have doubles. We have double of the data that we need in the first node because we just set the walker. We removed whatever was there before. We overwrote it basically. And now we can just say first node equals first node's next, get next, right? And then we break because we're done. We're done searching. All right, that's it for remove. So we basically found a way to bypass. Now the next thing we might want to do is let's do the constructor up here. This right here, the order doesn't matter. Inventory node walker again equals other dot first node. And we're going to say while the walker is not equal to null, we're going to say we'll just add because we don't really care. We're making ourselves match the products in. We could actually access this right here. If we made them public, we could access them directly, but we're doing it this way by making the node a separate entity. And add takes the, oh, wait a minute. I think I've got mismatch of parentheses. There we go. So add the product name and the quantity. And since we're calling add and add already takes care of adding the node into the list, we're good. So we have to progress, otherwise we'll get an infinite loop. So we'll say get next. There we go. And then the next thing we're going to do is we're going to look down here and look at print. So inside of print, inventory walker equals the first node. And then while the walker, or it shouldn't be inventory node rather, inventory node walker, while the walker is not equal to null, we're just going to print, right? That's all we're doing. We're printing the nodes as we go along. We know we have to update. This is kind of like using a counter in a loop, and you have to move toward the loop termination condition right here. So we're going to say printout system.out.println walker.get product name, and then we'll say has quantity, and then walker.get quantity. There we go. And of course, finally, we have to we filled in the remove method. It's kind of like our ADT bag. And now we filled in the print. Now we have to do the demo. So inside the demo, we're just going to test it. So we'll make two lists. I'll make two list references. One will give an initial list to inventory list, inventory list, list 1, and inventory list, list 2. List 2, I have not created an entity for it or an object for it. We're going to add carrots. Oops. I guess we want 100, right? So we'll do 100 carrots, list1.add hamburgers, and we're going to do 250. And then we're going to do list1.add pasta, and that will be 50. List1.add Coke, and we'll have 125 of those. And now let's see what happens if we take the list and just print it. We should get the carrots, hamburgers, pasta, and Coke. So I right-click the demo with the main in it, go to run, and if we don't have any errors, we should get what we expect. Coke's 125, pasta's 50, hamburgers 250, and carrots are 100. Okay, let's make an extra line here just to add some space. And I will do list1.remove. Let's remove hamburgers. Okay. And then we're going to do list1.print again. So I'm right-clicking and running it. And the second time around, you'll notice that hamburgers is missing, but Coke, which was the first node, has actually taken its place. So that's why the order changed, right? Because that's what we told it to do. We called add. All right, the next thing is we'll make another space, and this time I'm going to say list2 equals new inventory list based on list1. So this is going to test our copy constructor up here. So did it copy it correctly? And we'll know if it knows how to print the data, and we get the same data as list 1, right? Run it. There we go. And these have the exact same items. The order doesn't matter, but right, because carrots and pasta are switched. It's backwards because of the way that we did the copying with add. But it has all the items. It's pretty cool. Now, if we try to remove an item that isn't in the list, you'll notice that it just ignores it. We could throw an exception. We could print out, hey, that doesn't exist. You could do whatever you want. Okay? There's nothing preventing us from doing that. The sky is the limit. So I hope that helps if you were having trouble understanding how to make a linked chain properly. Now you have the 3 files. I'll make sure you get the code, the video, and the slides to make sure you understand it better. And please don't hesitate to email me if you're one of my students. Make sure to email me and ask questions. And I appreciate it. Thank you. Bye-bye.